Okay, so it's 9:15. Let's get started. Thank you all for coming, and also thank you for the ones attending online. We have a day full of interesting presentations. It's the last all-hands meeting for the bioCADDIE project, and I'm very happy to sponsor and do it here in La Jolla, where we will have great weather later today. The steering committee for bioCADDIE is shown here, the executive committee that meets very frequently, as well as the NIH representatives. I want to thank them in advance. We already had a discussion early this morning, and we'll continue after the meeting. And I also want to thank Elizabeth and Anu for running this project, on a daily basis and getting us all in line. So as you remember, our goal is to help users find shared data, build a prototype of a data discovery index, and interoperate in the NIH Commons under the FAIR principles, and do for data what PubMed did for papers. And one thing we want to do is search across repositories to find data sets. And I put the analog to PubMed here, because someone says, well, are you indexing repositories? Yes and no. Yeah, we want to know what repositories have in order to find the data sets inside them. So just like PubMed indexes the journals to find the articles that are inside them. So that's our goal here. And there are phases, and these are phases that I think are natural. First, we had to find the repositories we wanted to start indexing. So that's very similar to the criteria that NLM has in order to index a journal. We had to index repositories. And we relied on bioCADDIE indexing teams to reach out to repositories, map their metadata to DATs, a process that we know is not scalable, but it was necessary to populate the first DataMed prototype and then to get others to understand what the idea is. So phase 2 facilitated mapping into DATs by the repositories themselves and integrated the data set, which is the analogous to article, search across repositories using DataMed. In a phase 3 that is not within the present funding is to look inside the data sets, and we have some glimpses at it and will be shown today, but it's something that will be future phases of the project. So this I presented a long time ago, and it's one of the use cases. Find all data about astrocytomas grade 2 with IDH mutations, because of a case that I was very interested at the time, still am. What is the recurrence and mortality rates for this particular case? And you want to find different sources, including imaging, genomics, and medical records. So like I said, if you go to Google, you still don't find what you want. You don't find the data. You find some blogs, some articles, some other things, but you do not find the data. So there's no tab for data on top because it's not that simple. So DataMed, the DataMed 3.0 has now 77 repositories, old slide probably. And we have, if you do that search there, you will find the actual data sets. They are within repositories, and again, we do need to work on some issues regarding duplication. As you can see, examples, they're very prominent here in this page, but you do find pointers to where the data are on low-grade astrocytic gliomas in this case. So there is a translation, there are synonyms and so on that is done for the free text query on top in order to get the data sets. And it's a whole process involved. What you see is what users see at the bottom, the front end, but there is ingestion, there's metadata mapping and terminology server, all running behind the scenes in order to get the final product. But then the problem is how to rank these data sets they came up, for example. And they are all pertinent. They are relevant to my query. Which one is better? The one that came on top is genome-wide profile of astrocytic gliomas with 131 cases. The second was the expression profile of lower grade diffuse astrocytic glioma with 101 cases. So which one should be ranked on top? And there were many pages of results returning. And then you say, well, maybe the first one because it's bigger, but you don't really know because they have astrocytic gliomas. You don't know which ones are low grade. So let's say half are low grade, then probably the second one is better because it's already on low grade gliomas for the things that I was looking for. So that motivates looking inside the data set or having more metadata about the cases you're looking for. So biomedical researchers reuse data as reference controls and reuse software, produce new data, and publish results, and the results are data themselves. So that's all within the scope to index that data and provide the best result. So here's what I was referring to as currently we have metadata about the data sets in the repository. So who authored that data set, what type it is, standards used, landing pages, and so on. However, we are moving towards indexing some elements inside the data set, so the variables or the fields inside the data set. In this example, the age, the diagnosis, and grade are things that we know are present in the repository. But the ultimate goal is to even index at the value set, because then you really find, patients of a certain age range with a certain diagnosis, with a low grade, and so on and so forth. So it's a long ways, and we are still at the data set level for the most part, but we have projects, and you will see we're talking about the common data elements and the deployed project today that go one step deeper into this indexing. And like I said, the raw data is processed somehow with software systems to become derived data, and documenting how it became from 1 to 3 is very important as well. It's metadata that are important for us. So I'll just go quickly. That big data analytics depends on merging data from several sources, using proper software and proper computational environment, cloud in most cases. And when you have clinical data or clinical trials data with human subjects, you have additional levels of protection that are needed. And then we have to organize this original data process and create new data. So it's a big ecosystem, and everything needs to be interoperable, reproducible, reusable, in addition to being findable and accessible. So think about data sets that start one way, and they come in all shapes and forms, and you have to find the answer you're looking for. There's some degree of harmonization happening so that you can search across the data sets and use certain standards. So that's very important. So transformations, so that you're talking apples and apples. Then transformations in order to become processable by statistical software. That would be data that we wanted to have too, because it's a lot of work to get to that point. And many researchers might just be looking to that cleaned up data set in order to try their machine learning algorithms and so on. And then, like I said, a model that, for example, coefficients become data themselves, and that too needs to become available in a fair system. So indexing is labeling, cataloging, or tagging. And while we focus on the data object, it does relate to software objects and the containers for those objects, which should be indexed as well. bioCADDIE components are the community engagement, the metadata specifications that are DATs, software development for the prototype with a search engine and an indexing process that composes DataMed, and their collaborations with supplements and pilots that we funded through this grant, and you will see some presentations about them today. That's is what we call leading the data shop, the indexing, the ingestion, all the behind-the-scenes process. The data med is the front that you see, the user interface, and all connecting with the search engine. And then there's the data market out there, which relates to incentives to share data citation and outreach to others. So nothing happens in a vacuum. This afternoon, I will briefly explain the working groups that we have and how they connected and what their end products were. We work together. We have a lot of people in different places that were funded somehow by this project. And the metadata adoption were in two fronts, annotating existing data and then annotating new data with DATS, which was modeled after JATS, which is the journal article way of indexing. So we have DATS as our alternative to that. So several data repositories were included, many more to come. But it's important also that we're not done with those. We're optimizing the indexing some were done in more detail, some were done with more engagement than others, and there's still a lot to pursue here as we continue. Like I said, that there is a front end of the project, but there's a whole lot going behind the scenes in terms of the metadata specifications. So it's a standard for the metadata representation, repositories and data producers helping to transform their metadata into one that is searchable across all the repositories, with the idea that these aggregators or repositories have data sets underneath them that also comes in different shapes and forms. They aggregate and they harmonize in a certain way, and then bioCADDIE provides yet another level to search across these aggregators. And we do that with help from others as well. So an example of added functionality, as you know, data meta is open source and can be modified by others. And this was modifications that our colleagues from Mount Sinai did, and you will have a presentation this afternoon about this project. So we're very glad to see additions and improvements done of what we got started. We had supplements for Force 11 on data citation and implementation, which will be shown as well. There was a supplement called Count Everything, which was secure aggregating counts of relevant patients across different data sets. It's work that we intend to extend to what we can do with the few months of funding that we have left. Again, pilot projects from different institutions added a lot to our search engine. And more recently, we had the Dataset Retrieval Challenge, which had some winners that we'll be presenting today, and that we want to incorporate some of those results and algorithms into the prototype on DataMed. So in summary, we delivered the products DataMed, the DATS, metadata schema, 10 pilot projects were funded, 5 supplement projects, collaborations with BD2K and other projects, and the working group reports are all available online, and were all completed as we agreed. The near future, we will conclude supplements and pilot integration at the end of August, August 31st, this month. We will complete the core deliverables and find a home for DATS and DataMed, we're actively pursuing that, and continued discussions regarding DATS adoption and the need for DataMed to check that specifications are useful. What I mean by that is DATS and DataMed go together, and one helps to show why the metadata specifications are important, because they're used in searches of different kinds. So I find it extremely important that the work does not continue on the metadata specifications alone, but also in a way to show how they are put in practice, and that's done with DataMed. So with that, I want to acknowledge a lot of people. I think I'm making up the time that we wasted a little bit, not wasted, but used for nourishment outside. And a lot of people contributed to our project, and so we're looking forward to the presentations today. And our journey, is, again, continues to be towards a concrete, sustainable biomedical information commons, in which the data indexing is a fundamental aspect of it. And we want to go from our prototype DataMed and specification of DATs that started with a smaller group to now a much larger group, and have the DATs beat the submission standard, and DataMed become the product that we clearly can say is the counterpart for PubMed. And lastly, with my very badly taken picture of the Johannesburg airport that says, if you want to go fast, you go alone. If you want to go far, you go together. And that's why we did take 6 months at the beginning of this project to organize ourselves and to understand that we were going far, that we were incorporating a lot of different groups with very different ideas, and organizing them towards a common goal. So that's what we did in the past 3 years, and that's what we're doing now. Again, because we had 6 months to plan or reorganize ourselves to start the project, we have 6 months left in terms of funding in order to complete what's in scope of our project and improve what we have done so far. So you will see some of the beginnings of such improvements in the presentations today. And with that, I would just ask if you have any questions that I can answer right now, or comments, or anything you want to express. And I will repeat, and I ask every speaker to do that, to repeat the questions, because our people attending online can't hear you. So we'll do that. So with no questions, I think I'll go to the next presenter of today, which is Jeff and Hua, who are going to do a demo, always a risky activity. Oh, so he's risk averse. Hua.